Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Bashir bin Ahmad Tarmizi, and today I'm going to present our mini project, which is the title that we have chosen is the DC-DC buck converter. So I'm going to present my part, which is the introduction. So as you can see, this is the circuit for our buck converter. So what is a DC-DC buck converter? A buck converter or step-down converter is a DC-DC converter which step down voltage while stepping up current from its input supply to its output load. It is a class of switch mode power supply. So how does DC-DC buck converter works? The buck converter uses a transistor as a switch that alternately connect and disconnect the input voltage to an inductor. So as we can see in this picture, this is the circuit for the DC-DC buck converter. And for the introduction, in this paper, a DC-DC buck converter is proposed using a simulation circuit, multisim, and Simulink. And there's component that using resistor, inductor, capacitor, and DC power supply, which as we can see, just like this picture. This is the circuit that we will build in Simulink. Balance capacity and flexibility with integrated FET step-down voltage converter, because DC-DC step-down buck converter features a controller with one or more integrated FETs and an external inductor. They offer a balanced flexibility and ease of use, both non-synchronous integrated high side FET and external diode, and synchronous integrated high side and low side FET. Buck converter simplify the design process by reducing external component count. At the same time, having control over the selection of an external inductor lets you optimize your power supply for efficiency, size, or cost. No matter what your application is, we have DC-DC buck converter and corresponding design tools to help you address your power supply design challenges. So that's all for my part for introduction, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabihan bin Zaiful Bahri from class 2 BEEE, section 11. So now I will present my part, which is project methodology. So in this assignment, our topic of this assignment is the buck converter. So the buck converter is a step down converter and produce a lower average output voltage than the DC input voltage. And then the methodology for this project consists several steps. The theory of DC buck converter is very important in this project in order to get clear understanding on what the project is all about. So for the design specifications, in this design, the buck converter operates in continuous. It's designed the performance in terms of output voltage, current, and output power is estimated. However, the effect of non-idealities due to components are observed. The design specification are given as follow. Input supply are given 24 volts and output voltage is 12 volt. This satisfaction of analysis the real case buck converter is depend on decent modeling of component. For sake of design such realistic buck converter, some variable have been considered and investigated. And then this is the principle of step down operation. As you can see from the figure 3a, this is the circuit of the step down operations. So the principle of step down operation of DC-DC converter is explained using the circuit shown in the figure 3. When the switch 1 S is closed for time duration T1, the input voltage Vin appear across the load. For the time duration T2 is switch 1 S remain open and the voltage across the load is 0. So that the waveform of the output voltage across the load are shown in figure 3b, which is I will show you later. This study is using MATLAB Simulink to design the buck converter. So this is the figure 3b about voltage across the load resistance. So for this understandable methodology for teaching the buck converter must at least include explanation of switching stage and principle of operation. Establish switching state and explain the principle of operation. Buck converter function is must maintain a regulate output voltage lower than its input voltage. For this reason, it's also known as the reduced converter. Also, diode must be high speed to prevent the switching frequency of the power transistor affect its activation time, represent the loss of the inductor, while represent the loss of the capacitor, and are included in the equivalent circuit to obtain a more realistic modeling of the system. So, in another figure, it shows the equivalent circuit for buck converter. And this one also state the component of the component through the circuit. The list component. So in this project, we using MATLAB Simulink. So the simulation was conduct using MATLAB and Simulink software from National Instrument. This software is capable to show result by using the oscilloscope and also observation from the simulate output signal was required to determine the difference between the calculate and theoretical result, and the result from the value output power from the circuit, and also the simulation result. It shows that the output was approaching the calculated parameter value. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Farid Saikal, and I will proceed with calculation of our project. So the given, so this is a sample circuit for buck converter, DC to DC buck converter. As you can see here, the question given is we have to use 34 volt to get output 12 volt. So we decide to use as our frequency, we decide to use 51,000 kilohertz, and as our resistor we use 20.1 ohm. So the duty cycle here is 0.5, and our inductor, we get 120 and 120 microhenry, and for capacitor is 20 microfarad. So this is our circuit, and this is the result waveform we get. So we proceed with our simulation. So this is the circuit that we have built. And so in this is 24 volt. Minute. This is 24 volt, 20.1 ohm. And this is our waveform. It's a bit lag. Okay, this is voltage output we get 12 volt. So that's all for me. Thank you.
Assalamualaikum. My name is Amir Faiz bin Mazlan. So for discussion of this project, we know that the simulation and result are characterized based on each input voltage independently in order to show their corresponding output parameter and performance analysis. The parameter and performance analysis consider buck converter. At first, it is difficult to find a component that suit for the project, but we managed to do it as we find something that can be used. In this buck converter circuit, we need to find the component that suit for 20 volt output. For the component, we use MOSFET IRF 520NS, diode inductor 97 microhenry, capacitor 16.5 microfarad, and resistor 20.1 ohm. Then in the graph, we can see the final value is 0.5. It's same value in calculation of duty cycle. The result representation include the parameter of the system such as the voltage and current in MOSFET. Inductor and diode as ripple voltage and ripple current, and the output current, voltage and power waveform. A study was performed on effects of duty ratio on power losses and effect of ripple voltage. The current conduct for a short period having a current of 0.5 during unsteady and excessive current flows through MOSFET for a very little time. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Jalmi. Today I will present about our DC to DC buck converter conclusion. Okay, conclusion is, in this assignment we have done a DC buck converter. We have described about the voltage, current and peak current mode control of the project assignment. The simulation model were done using Simulink software. The result and the circuit were shown above in result page. We also have learned lots of things, which is how and where to use the components such as MOSFET, IRF 520NS, diode, inductor, capacitor and resistor. We have got the value of simulation in the graph, and the calculation are the same, which is the project was successful. Okay, A DC buck converter is a type of power converter used to step down or reduce the voltage of a direct current power source. It is widely used in various applications to efficiently convert higher voltage levels to lower voltage level. Okay, here is a step-by-step explanation how a DC buck converter works. Okay, for input voltage, the buck converter takes in a higher voltage input, usually from a DC power source such as battery or an external power supply. Okay, for switching circuit, the heart of the buck converter is a switching circuit consists of a switching element, often a transistor and a diode. The transistor is typically operate in a switching mode, continuously switching between on and off state. For the control circuit, the control circuit monitors the output voltage and adjusts the switching operation to maintain a stable output. It usually includes a feedback loop that compares the output voltage with a reference voltage and adjusts the duty cycle of the switching element accordingly. For inductor, the inductor is an essential component in a buck converter. It stores energy when the switching element is on and releases it when the element is off. This energy transfer helps in reducing the voltage level. Okay, the advantage of a buck converter include high efficiency, compact size, and precise voltage regulation. It is commonly used in applications where efficient power conversion and voltage reduction are required, such as in portable electronic device, power supplies, and automotive system. In conclusion, a DC to DC buck converter is a power electronic circuit that steps down the input voltage to a lower and regulated output voltage. It achieves this through a switching mechanism controls electricity, inductors, and capacitors, providing an efficient and stable power supply to various electronic devices and circuits. Okay, that's all from me. Thank you.